Hello everyone, in this video I'm going to go over how to do the longest type of picket fence for this unit, which is a grams to grams problem. So for this question, how many grams of SnF2, that's what we're looking for, are produced from 300 grams of HF? So when you see grams and grams in the problem like twice, you're going to have to find the molar mass of both of those substances, and you will have to use the balanced chemical equation. So I'm going to go ahead and start the problem on the next slide. So I'm starting with 300 grams of HF. So whenever we're starting with grams, the first thing you want to do is get that into moles. And we do that by calculating the molar mass. So H is hydrogen, which is 1.008, plus F, which is fluorine, is 18.998. So my molar mass is 20.006. So 20.006 grams of HF. Remember, this is molar mass, so this many grams is equal to 1 mole of HF. So all I've done so far is converted grams into moles by calculating the molar mass. Now that I am in moles, this is when I can use the balanced chemical equation. So I can convert between moles of the substance I have into moles of the substance I want. So again, if you're stuck, write the same unit that's here, write that here. So moles of HF, according to the balanced chemical equation, we have 2 moles of HF, so that's where that 2 is coming from. And the thing that goes above it is going to be moles of the substance you want your answer in. So in this question, I am looking for grams of SnF2, but first I got to convert into moles of SnF2. And according to this balanced chemical equation, put a 1 here as a placeholder, we have 1 mole of SnF2. So I converted from moles of the substance I started with into moles of the substance I want my answer to be in. However, they're asking for grams of SnF2. So I have to go one more step to convert moles into grams. Again, we do this by finding molar mass. So molar mass is saying 1 mole of SnF2 is equal to the molar mass of SnF2. So Sn is tin. Let's see, where is Sn? So tin, 118.71 plus F2, so that's the fluorine, which is 18.998 times 2. So my molar mass is 156.706. So 156.706 grams of SnF2. So I converted moles into grams. So last thing I need to do is multiply everything in the top. So that 156.706 times 300 divided by the bottom, everything multiplied together. So 20.006 times 2. So for my final answer, if I'm doing 4 significant figures, I would get 117. I would round this 4, would round that up to 5 because there's a 9 after it. So 1175, so 1,175 grams of SnF2 would be my final answer. All right, let's do another example problem. All right, so this one is asking how many grams of NH4NO3, so this would be ammonium nitrate, are required to produce 33 grams of N2O. That's dinitrogen monoxide. So again, in this problem, I'm seeing grams for both substances, so I will have to find the molar mass of both of those substances. I'm going to start with what the problem gave me, 33 grams of N2O. Again, if you're ever starting with grams, the first thing you want to do is get it into moles. And the only way to do that is to calculate the molar mass. So we have N2O. So nitrogen is 14.007 times 2. Plus oxygen we can say is 16. So 44.014. Again, this is grams. That's what I just calculated. Molar mass. And again, since this is molar mass, this is equal to 1 mole. So all I've done so far is I've converted grams into moles. Now that I am in moles here, now I can use the balanced chemical equation. Again, the numbers in front here, so imagine there's a 1 here and a 1 here, those represent moles. So once you have moles, that's when you can use the balanced chemical equation. Again, if you're not sure what unit goes here, it should be the same unit that you have here. So moles of N2O. According to the balanced chemical equation, that is 1 mole of N2O. And then whatever goes above this, you should also be pulling that number from the balanced equation. So moles, and according to our problem here, we need to get this substance here. Yes, it needs to be in grams, but the first thing we have to do is get it into moles of NH4NO3. NO3. And again, according to the balanced chemical equation, we have 1 mole of NH4NO3, which is ammonium nitrate. Again, both of those numbers are coming from the balanced chemical equation. And sometimes this is how it works out, where you have a 1 and a 1, and that's fine. That's just what the equation is telling us. So now I converted moles of N2O into moles of NH4NO3. For my last step, I have to get this into grams. And again, the only way to do that is to calculate molar mass. So molar mass says 1 mole of NH4NO3 is equal to the molar mass, which we're going to calculate and put here, of NH4NO3. So it's NH4NO3. So we have 2 nitrogens because it's NH4NO3. So I'm going to do 14.007 times 2 because there's 2 nitrogens, even though it's not written like this. There are still 2 nitrogens in the problem. Okay. So I'm going to include both of those. Plus, we have H4. So that's hydrogen. So plus hydrogen 1.008 times 4. Plus our last element, which we have, is the oxygen. There's 3 of those. So 3 times 16. So my molar mass is 80.046. So 80.046 grams of NH4NO3. Now we're going to multiply everything in the top. So the 80.046 times 1 times 1 times 33. Then we're going to divide by everything multiplied together in the bottom, which just is the 44.014. I'm going to go 4 significant figures. So 60.02. So 60.02 grams of NH4NO3.